Hello friends. In last section, we discussed about multi-class classification in theoretical, where I explain you what could be the consequences if you didn't take care about the classification matrices, evaluations, then what kind of problem you can face in your model training. Today, in this session, I will especially do the practical for you, where we will see practically how multi-class classification trainers fit in our day-to-day work. So let's start this without taking much time. For this multi-class classification, we will use the trainer SDCA maximum entropy, and this is the ML.NET concept. If you need more detail, you can check here ml.net concepts. Let me turn off my camera. So this is multi-class classification. There are several trainers supported by ml.net. I will try to complete one by one all the trainers. And now the important things which you need to understand. There is a small difference here as compared to binary classification, because in the binary classification your output was in the score, that is the single column type, and predicted label is boolean. But in the multi-class classification, our score is vector. Now it's array, means collection of singles, and then the predicted label is, now it's not only the label, it's a key. Yeah, so that's the difference here, because the multi-class classification means you have more than two or more than two classes. So your object can belongs in more than two classes, means. Yeah, so this is the multi-class classification. This I will try to explain to you, and for this we definitely need, what do you need, do you know? We need data set always, because nowadays we are working on the tabular data set. So we need CSV data set where we can recognize and we can train our model, and we try to understand how to train the model for multi-class classification using SDCA maximum entropy multi-class trainer, right? So for this I have downloaded the data from here, Kaggle, known name Kaggle as repository datasets in the machine learning. If you need to understand this, so you can explore the Kaggle. I already inbuilt or embedded the URL in the notebook. So today we will do this practice along with this data for all multi-class classification. I would like to prefer to use this, because we can try to figure it out which trainer perform well in what situation. So this is the data set for the gaming behavior, the online gaming behavior. This data set here, we have several columns for the data set, where we have player ID, age, gender, locations, genre, play time, hours. Yeah, so many things. And at last it's engagement level. Engagement level is basically the outcome, that the retention level of the player, which reflect, it could be, it may be high, medium and low. So you can see here we have three classes, right? And then the target variable, yeah, engagement level, because this engagement level will give us the final outcome, and we will predict. So what we will predict using this the data set, we will predict based on the parameter what could be the engagement level of player, right? That is the prediction using this. So let's start practice, and where we try to see how our classification will fit. So what I did already, this data set is with me. You can see here the data set with me, but here you can see there are several columns which are text column, and several columns are numeric column. So the what is the fundamental concept? For the machine learning model training, all columns must be numeric. So here we will convert the text column into numeric columns, and then we'll continue. And this last column is engagement level. So to continue work in this order, we need some code that will utilize for um, the training, loading the data, creating a pipeline, then adding a trainer, and then provide the training for the trainer. So let's continue with this. I will copy this from any previous sessions which we already did. Let's copy from here some basic things. First, we need NuGet package. It's that you use the NuGet package. Oh, the important thing, guys, you need to select the kernel. So this is .NET Interactive. Otherwise, your application will not execute. So don't be surprised if it's not executed. It should be used by default here. Or if it's not default, then you should use. So now you can see it's creating trouble. This means I have to reopen this. So your model, load the NuGet packages. Let's execute this. And then we need to copy what? Input and output model. So I have generated the input and output model for this. Let me copy that. This is input and output model player engagement data, where we same structure as you already aware about it. Yeah. And then last is label. This is the engagement label, would be definitely the label. And then we have output data, means prediction class. In the prediction class, the engagement label, yeah, is this, and then collection of score. Right. Then move it forward. And the next process is we need to prepare the pipeline, but before pipeline we need to load the data. Let's load the data. Load the data here. Yeah, load it. And now we need to change the class name and then CSV file name as well, right? The CSV file name also we need to change and then execute this. So load the data into our ML context. Data is loaded. Now the chance for pipelining. So let's do the pipeline. So for pipeline, as you aware, we have to do one hot encoding as well. Let's do one by one. So let's look at the CSV file once more. In our CSV file, if you can see the player ID, it's not useful. There is no use for the player ID. What you will do for player ID, you can simply remove this column. There is no need for player ID column, right? So we'll remove this column. Let's prepare the pipeline. Prepare the data pipeline. Here we will do the preparation of the pipeline. How? One hot encoding. We will do the one hot encoding, and there are some columns. What are the columns for one hot encoding, guys? The string column. So we have gender encoded, and then we can add this. Location, we have January, we have, yeah, January, we have, and then game difficulty encoded, okay, difficulty encoded, fine. What else? Is no need to. Okay, this is done, and once this is done, and what we need going forward, hold on, this, Copilot plays interesting role here. So let's keep it simple. First, try to understand how many string columns we do have. Gender, location, genre, game difficulty, these are all are the string columns. So we have string columns of these, and we will leave this because this is the label column, right? And after this, what else we do have? We have one more important thing, guys, which you need to know. We need to remove a column, right? Which column? Player ID. So let's remove this from here, ML context. Let's remove the column. So here we have option is called, what option we do have? Transformers dot drop column, drop column, and then the column name. We can put the column name here, which column we like to drop. So there are two options. Either you can use the name of and then name of, and then this will remove, this will drop the column. And once our column is dropped, next we need feature, means concatenate. So we will concatenate all the columns. What all the columns? The encoded columns and the available columns, which is already in numeric column. So we need to club those here. Once those columns are clubbed, and then what is next? We need to append trainer. Before appending trainer, for the multi-class classification is a very important topic, guys, is conversion. You should not forget about conversion. Why conversion is required? Conversion of string label to key. This is most important thing, because now we engagement label that we have, engagement label that is, that could have multiple values, yeah, which you can see there could be 3 classes: medium, high, low engagement labels. So this is important for multi-class label. Here you can use transformers or conversion map value to key. Here you need to map this. This is very important topic for multi-class. Yeah, when you use multi-class classification. Once you've done this, then the next is we need to add trainer. Yeah, add trainer, SDCA maximum and SDCA maximum entropy. Yeah, this trainer we will add here. And for what? Features. This trainer VS, the trainer is here multi-class classification, trainers SDCA entropy. We use this and then use label and features. Now the next thing, this we explained in the previous session. Before training we need map values to key, and after training we need reversal, means conversion original values back, means we need to convert back keys to original string values, because that is required for prediction. Yeah, one thing I have noticed, if you notice, then would be nice, you can see the all columns are not included. So let's include all the columns, because here encoded columns are included, but other columns which should be included, that are not included. What are the columns, guys? We can see, okay, age, gender, location. I have added these columns, guys. So age, play time, hours, these all the numeric column which already exist in our data set. I have added those along with the columns that we have performed the one hot encoding for that. So in this pipeline, let's see this pipeline again. The first start with the one hot encoding, where all the strings columns one by one we will convert into one hot encoding. Then concatenate the columns, let's say, where we add one thing in features, and then adding all numeric columns and encoded columns. And once it's done, then we need to remove the unnecessary column which does not add any value, because player ID definitely will not add any value in the model training. So we'll remove that. And then for multi-class classification especially, we need to convert the label column. What is the label column here? Engagement label. This label column we need to convert into value to key for the model understanding, for the model training, and then apply the trainers. In this session we apply the trainer SDCA maximum entropy. In going forward we will also do the practice for other trainers. And then once the trainers is applied, the next section is we need to convert keys to value in the original format, because this is required when you do the prediction. Now let's move for further thing. So here pipeline is complete. Once the pipeline is complete, we know what to do next. The next session is we need to split and train the model. Yeah, split the data, it's training the model. Yeah, as simple as. So this training is complete, and the next stage we need to perform the evaluation. What to evaluate here? You need to careful, because this data I copy from previous session. So here we need to use multi-class classification, evaluate your column, and then yeah, this label and the predicted label, yeah, that we have. Let's evaluate. So evaluation is done. We can see what is available here. Matrix, print matrix. Let's do this. I prepare a code base for you to save the time to predict generating matrix, yeah, for our classification. Let's execute this. Okay, let's execute this, and we can print a matrix. Here we can print this, print matrix, and then matrices. What's happened? So the matrix is printed, guys. You can see the matrix is printed, but you know the shocking is macro loss, and this most of the thing is, you know, your accuracy is 51%, 51.8% accuracy given by this model, this trainer. That's interesting to, you know, going forward for your practices. Now we will realize what is the problem exactly. What problem could be? Either our pipelining means our training is wrong, or either we choose wrong trainer. So this I will explain you in detail in next session. Let's do this, continue your practice, guys, and we will talk in the next session what is the problem here and how we can improve our model accuracy. This is exactly that I want to show you for your practice. You can now realize this, what kind of problem can we, if you have a data set and you made somewhere mistakes, either mistakes choosing the right trainer or mistakes in the data pipelining that we created. Wherever mistake happened, your accuracy goes down, and that's perfectly, that's really I wanted to show you guys. So in the next session we will dig it down more detail. What is mean by micro accuracy, what is macro accuracy, what's the log loss, and what is log loss reduction. And here you can see the confusion matrix is the 3 columns now, but in the binary classification you know only confusion matrix, which is the 2 into 2 matrix, yeah, but now the matrix is 3 into 3. So in next session I will give you a step-by-step explanation, no confusion, no hype, it's a practical and for your understanding only. Stay tuned, continue your practice, and see you in the next session. Thank you very much.